Hello, welcome to the lecture on intermediate code generation. Intermediate code generation, no, if you see till some phases of compiler, all the phases put together, no, they will generate the intermediate code. And now, given that intermediate code, the last phase, the backend, can take that intermediate code and generate the machine code. Therefore, having intermediate code is very important if you want to build new compilers for other machines. Let us see intermediate code. Intermediate code is divided into two parts, will be of two parts. One is a linear form, another is tree form. So, in the linear form, there are examples which I have put up here. One is in the form of postfix notation, another is in the form of 3 address code. And when you look into the tree form, there is a syntax tree formation and a directed acyclic graph formation. So, in the syntax tree, it is kind of condensed parse tree without variables, and only there will be only terminals, no, and meaning that it does not change, right. So, these are some of the characteristics of the syntax tree that we already know, right. So, a b plus, then again a b plus, then again plus plus star at the top, right. In the case of directed acyclic graph, directed acyclic graph will not repeat any repetitions, if at all, if it is there. So, a b plus, no, which was there, now it is not repeated, only directly plus plus is getting a link. So, just refer to that to the representation which is already generated on the top. Okay, so we have seen the example of a plus b star, a plus b plus c, right. Then we will see in detail number of other things. Okay. So, now for example, let us say as part of the intermediate code generation, why do we need this? For you might have already designed a compiler for C programming language for Windows machine, and now you want to design the C compiler for Unix machine. Then you need not change everything. What you should change is only the phase at back end. Your front end, that is lexical analyzer, syntax analyzer, semantic analyzer and intermediate code, will remain the same, and whatever is coming out of this intermediate code generator, that one is going to be same for all of them. Intermediate code is same for all the machine, it does not change, right. Then only the target code generator and the code optimizer needs to be changed, so that you can write the compiler for the different machines. Let us say in the case of Java, in Java there is something called as bytecode. Bytecode is an intermediate code. You generate the bytecode on one machine and then you send it to some other machine, and on that machine that bytecode is executed. The reason is every machine will have interpreter which is suitable to that platform. Every machine will have only the backend changed, that is target code generator and code optimizer. There are various popular intermediate forms available, mainly linear form and the tree form, right. Mainly linear form and the tree form that we have already seen on the top. Among all the four options, the most important and the popular one is 3 address code. So, this is 3 address code. So, we will look into the 3 address code. It is globally accepted and it is popularly used. So, what are the various 3 address codes, types of various 3 address codes? We will see first of all those various types of 3 address codes, and then we will see the examples of other types. So, first one, I have listed here all the 7 possible types for a high level language. So, when we want to convert to 3 address code, whatever high level language is there, we have these 7 types of instructions available, right. So, whatever is available in language, it will be converted to any one of these 7 representations. We shall see how it could be done for if, for while, then for while statement, for statement, switch statement, and then convert it into 3 address code little later once we complete these 7 basic types of possible statements. So, first one is x equal to y operator z. So, it is a binary operator, x equal to a plus b, a minus b, a divided by b, and so on. There are there is operator and there are 2 operands which are required. The second one is x equal to operator z. which is unary operator type of statement, minus b sort of thing, and the value will be assigned to the left hand side variable. Third one is x equal to y, which is a normal assignment statement. If x The fourth one is if x relational operator y, so relational operators we know that greater than, less than, and so on. So it will make a jump to some statement, that is go to L, so which is nothing but conditional go to. If the condition is satisfied, then it will make a jump to the statement number L, right. So that is conditional go to. In the fifth statement, you see there is go to L, which is nothing but unconditional go to, right. And the sixth one is nothing but simple array indexing. So to this array index value a of I, maybe I will be having 0 to and some number, the value will be assigned, that is x, to the appropriate index, and we can use it like y is equal to a of I. So that value also could be extracted and could be given to some of the variables as required. The last one is the pointer. So we normally say x equal to pointer p. So x is a variable which is of type pointer, and there is a p pointer which is pointing to it, right. So x is going to have the value of the pointer variable, and to have the address of that variable, normally what we do is we say address of x, right, ampersand of that variable x. So y is equal to address of x. In this way we can say that no, all the 7 possible type of statements at the 3 address code we have listed. Now let us see various things in which various ways in which now we can represent the 3 address code. Traditionally people have been using 3 popular representations of 3 address code. It depends on the implementers of what they choose. Depending on their choice, various compilers are having different representations usage. There is nothing like one is superior and one is inferior, everything is in use, understand. Let us assume we are having statements like this: minus a plus b minus a plus b into bracket c plus d plus into bracket a plus b plus c. Now for this statement, 3 address code is written like this. After writing the 3 address code, in some way we need to store it inside the computer. When it has to be stored in the computer, it must be stored in some format, and people have come up with various ways in which data could be stored. So they are quadruple, wherein there are 4 elements, then triples, then indirect triples. Let us see the difference of each of this. Okay. So we will take this example, and initially what we will do is we will prepare the appropriate 3 address code manually, right. So minus a plus b into bracket c plus d plus bracket a plus b plus c. So there are 3 brackets, and then let us break it up into 3 segments. Let us say t1 equal to a plus b. So the first bracket is finished, and then minus of t1. Minus of t1 is the first element which is evaluated, so that is stored into t2, right. And we are just numbering it 1, 2, 3, 4, 5 and so on in the proper way, right. So let us say again the c plus d. So c plus d is stored into t3 variable. So every time we have given t1, t2, t3, t4, t5 all temporary variables, and then so it becomes easy for us at the time of generating the 3 address code. This is the technique which we need to follow, right. So t2 and t3 we know it is minus a plus b, and it is nothing but c plus d. So we need to multiply it. So t2 into t3 is nothing but the first 2 brackets are finished, and then we are storing it into t4. So that the 4th instruction, we are at the level t4 equal to t2 into t3. In the 5th instruction, what we are supposed to do, we need to evaluate the last bracket. So a plus b and then again plus c, right. So t5 and t6. So at the instruction number 5 and 6, at the step number 5 and 6, we do this a plus b plus c computation. So once this is done, then we are interested to see, that is t2 into t3 plus t6 has to be done. So that t2 into t3 is already there inside t4. So at the 7th level, 7th step, what we do is t7 is equal to t4 plus t6. Now this is the 3 address code for the expression minus a plus b into c plus d plus a plus b plus c, right. Using this we need to now have the various formats which are available. We will use the formats which are available for the same this one example, right. So the quadruple is saying that there will be 4 items, and 4 items means what? There will be 4 things which we need to store. one is operator, operand 1, operand 2 and the result. So just the same 7 statements would be kept here, and the same 7 statements, no, just see the first statement. First is saying operator is plus, right? So I note down that operator plus, then two operands are a and b, and then the result is the last one, last column is the result one, where you are going to store the content. That is nothing but the data is supposed to be assigned to which variable, t1. So in this case t1, right? So step by step, if you see in the second statement, the operator is minus, so minus is written inside the operator column, and there is only one operand, that is t1. So t1 is written there in the operand 1. t2, the second operand is not present, so dash, and then you are storing it into t2, right? So likewise third statement, there is plus, then cd, and then it is stored into t3. Then there is star, then t2, t3, and then stored into t4. In the fifth statement, there is plus, then a, b, and then it is stored into t5. In the sixth statement, there is plus operator, t5 and c, and then it is stored into t6, right? Likewise seventh, so plus, then t4, t6, and then into t7. So if you look into the advantages and disadvantages, no, statements can be moved around little bit here and there, and that is the most advantageous thing is that it will take too much space, and no, that would be a possibility of wastage in this. So if there is dependency, again you need maybe you have to check whether really the instructions can be moved or not. So you need not wait for the instruction execution for a long time. So interchanging instruction is possible. So this is one way of writing the representing the code, intermediate code, right? And the second way is the second one is the triple representation, wherein there will be three elements, right? So only those elements which the target one is, the result one is not there, the rest of the things are there. So operator is plus ab, then operator is minus, and the first one, the statement number 1 itself is the outcome of that, right? So minus of a plus b, right? So in that way you will just put the numbers. So in that way the data gets compressed little. Then again plus cd, then we are having the numbers 2 and 3. So 2 and 3, so minus of a plus b plus again c plus d, right? So that is done at the fourth level. Then 5 is a plus b, then 6 is 5 and c, so a plus b plus c is finished at 6th level, and 7 is saying that 4 plus 6, so that is all finished, right? So in that way we can create the triple representation, or the format, triple format for the intermediate code. So advantage of this is space is not wasted. Disadvantage is statements cannot be moved, right? It becomes little rigid, because once it is finished, then it is written at the level 2, then you cannot change that, right? Likewise at the fourth, 2 and 3 is present, so if you cannot change the second and the third statements, right? So otherwise everything will be wrong, right? Likewise at the sixth also, there is 5 present, so 5 you cannot change. In the 7, 4 and 6 is there, so 4 and 6 you cannot change, right? The last representation is the indirect triple. Indirect triple is nothing but the way in which it is similar to a pointer, understand? And it's like it is pointing to the triple representation. It is indirectly referring to the triple representation. So just to make it little different, the numbers instead of 1, 2, 3 decimal numbers, there are Roman numbers that are kept here, and this indirect triple bracket 1 indicates what it is referring to, somewhere some entry which is present inside the file, right? So there is nothing like it is a pointer. The statements here cannot be moved. 2 memory accesses would be required. Why? Because I am saying it is pointer. So you are having pointers to be to the instructions. That is, it will go to the pointer, get the address, and then go to the appropriate instruction file, and then take the instruction itself from that place. So this is how your normal representation of intermediate code is going to be there. So in the exams, what will be given to you would be like the expression would be there, and based upon that expression you will have to first of all manually create the 3 address code, generate the 3 address code, and then the equivalent representations, quadruple, triple and indirect triple, you need to generate, right? So I am again saying that no one is superior, almost everything is in use, right? So next is we'll see the other representation techniques for the various types of things, like if then else, go to, and other things, right? So first is let's say we will see what is the concept behind the backpatching. Backpatching means what? Leaving the labels initially what we will do is we will leave the labels as empty, and then we'll at the later stage no we'll fill up these labels by some numbers, right. So let us take an example of if then else. So if a is less than b, then t equal to 1, else t equal to 0. This is what we need to do. Okay, so what I will do is I will prepare the intermediate code for this, and let that go to statements be kept initially with dash. Okay, then finally we will fill up everything. So let that be started with I plus 1, I plus 2, I plus 3, I plus 4. In the memory we don't know at what will be the value of I, right. So considering that if a is less than b, go to dash, then t equal to 0, right. Then go to I plus 1, t equal to 1, and I plus 4 like the last stage. Okay. So now if a is less than b, if a is less than b, then t equal to 1. So where it should make a jump, it should make a jump to I plus 3, where t equal to 1 is already assigned. Okay, else t equal to 0. So if this condition is not satisfied, it will remain it will go to I plus 1 statement, which is t equal to 0. But if now see, if I don't write go to jump statement there, then what will happen is t equal to 0 is executed, and then t equal to 1 also would be executed. So we need to bypass that t equal to 1 I plus 3 statement, and that's why no what we are doing is at the I plus 2 instruction, at the instruction number I plus 2 or the number I plus 2, we are saying go to I plus 4, so that I plus 3 statement is bypassed. So this I plus 4 and I plus 3, this we are going to put up little later, and this concept is known as backpatching. Okay, so in the exams, in the gate also sometimes most of the times these type of questions are coming up in front of you. So if you are not able to understand, don't worry, I am going to take one more example with little complex example, so that you will be in a position to understand it properly. Let us see this. If you see here, there are three conditions, T1, T2 and T3. Three tasks are supposed to be executed, and in that there are three conditions. A is less than B, then C is less than D, and E is less than F, right. So condition 1 and condition 2 or condition 3, and or both conditions are in between, conditional. This is compound condition, right. Now how to generate the intermediate code for this? Similar things that we have applied here in the beginning initial part. So the same thing we are going to do here. What we have done was a is less than b, go to this some statement and then go to again, right. In that way, if you see, I have just replicated everything in this way, and I have kept it prepared it for you. So if a is less than b, go to dash, t equal to 0, right. Then go to something t equal to 1, if t1, t2, t3. In that way, three variables t1, t2 and t3 are supposed to be initialized, is equal to 0 or 1, 0 or 1, 0 or 1, in that way. Okay. So if c is less than d, go to dash, t2 equal to 0, go to 108 and t2 equal to 1, right. And similarly, if e is less than f, go to dash, t3 equal to 0, go to dash, t3 equal to 1, and finally we need to merge up all these conditions. So t4 is equal to there are t4 and t5 variables also, which we need to create, because only one condition and another condition, and in the next part the T1 and T2 or T3 has to be executed. That's why as part of 3 address code, T4 is equal to T1 into T1 and T2 is stored into T4. T4 or T3 will give us the appropriate result, right. So T5 is the case. So now if the first condition is true, if the first condition is true, then what it has to do is it has to go and check the second condition. So where it has to go? It has to go to 103, right. And if the second condition is also true, it has to go to 107. So T2 equal to 1. And if the third condition is true, it has to go to the 111, where T3 equal to 1. So if all the three conditions are true, then T1, T2 and T3 all are set to 1. And then finally, if the conditions are satisfied, T1 and T2 is again set to 1, T4 will be equal to 1, right. 1 and 1 is 1. And in the T5, we will have T4 that is 1 or T3. So anyway, in this case both is 1, so T5 is set to 1. So in this way there is one channel, right. So T1 is equal to 1, T2 equal to 1 and T3 equal to 1. So for that we have written the address is 103, 107 and 111, Now come back to the previous in the code. Look at the code number, line number 102. In the line number 102, you are having, if this condition is false, if the condition is false, it will not going to make a jump to 103. In that case, you need to set the value t1 equal to 0. So that is set at 101 line number, right? So t1 equal to 0 is set at 101 line number, and then what it has to do, it has to make a jump to, or it has to bypass that 103 statement. So what I will do is, I will write go to which number, 104. So that initialization is done, t1 equal to 0, and it is making a jump to 104. So similarly, look at 106 line number. So 106 line number, if you see, go to 108, which is bypassing t2 equal to 1, because it has already set t2 equal to 0. That's why it came there, right? Likewise, if you see t3 equal to 0 is set, and then go to 111. So it will bypass t3 equal to 1, which is at 111 line number, right? So 112, it will make a jump, and then continue from that point. So this is how the intermediate code is generated. We have created one, we have used one condition and compound condition, and we generated the intermediate code, and then what we did was, we have kept initially the dash as it is, and then we filled up the values little later. This concept is known as backpatching. Okay. Now we are interested to see what are the various ways in which the loops could be represented, right? So we will see what is while loop like. So I have just prepared a small flow chart, like, so if the expression is evaluated, or if the equation or the expression condition is false, then it will do something, and if the condition is true, then it will do something, right? So it will, when the condition is true, it has to execute some statements, and then again it will remain inside the loop till the condition remains true, right? And once the condition becomes false, it will go out and then do the regular work. So what will be the appropriate the intermediate code for that? So let's say I am using two labels, L and L1 sort of thing. So if E double equal to 0, then go to L1, right? Go to L1. So if the condition is true, if the condition is equal to 0, go to L1, otherwise it will remain inside the loop and with the help of go to, right? So go to L, go to L, go to L. So the statements will be executed if the condition is true, otherwise at one level it will be false, and then it will come out, right? So this is one way, simple way. Let's say this is what we are in the high level language. No, normally we do like this, right? So while it will remain inside the loop, and the condition has to be made false for one time to come out, right? So code optimization, if you see, now this is another way in which you can represent. So let's say L, if E go to L1, so where the statement is executed, and then go to L, and at one level you can say go to last. So this is also another way of representing the while loop. Both are same actually, right? So code optimization requires identification of loops, but where you don't see anything, any while, you just see the normal plain text, right? So that is what is going to be there. Now if you see here this example, while a is less than b, do x equal to y plus z. So if this is there, then what will happen? There may be infinite loop, understand, there may be infinite loop, as this, in this case, a or b is not modified. This is just for an example. In this case, in the while loop, a or b, a is less than b, and x equal to y plus z, only this much is there. So a or b is not modified, so resulting into what? Resulting into an infinite loop. So such type of things may also be possible, right? So however, let us see with the help of some other example. So let's say L1, the same example in different way. Let's say in the 3 address code, L, then if a is less than b, go to dash, then go to last, right? L1, what it will do is t equal to y plus z and x equal to t, and then go to the top one. That's how loop will be created. So this is an infinite loop as such, right? So go to L1, because we are not modifying a or b, and the condition that we are checking is a or b, right? So whatever the initial value of a or b would be there, a and b would be there, that will be continuously be in use, and it will never come out from this loop. However, this is an example of an infinite loop. Okay, now this is the simple representation for the while loop that we have seen. Next, what we will see is for statement. In the for statement, there are normally it is broken up into three parts. your initialization, your condition, and then the increment statements and so on, right? So E1, E2 and E3, that these are the three sections, let's say. So initialization, if you see the inside the loop, there is initialization, then checking for condition would be done, so which is nothing but the things that we have seen in the while loop. So if it is, the condition is true, it will remain inside the loop, and at one place it has to, that condition has to be made false, it will come out from that and it will execute some of the statements. And executing those statements is nothing but the execution of the statements is the statement that we want to execute inside the loop, right? And there has to be some increment decrement statement also within that. Okay, so now what will be the appropriate intermediate code for the for loop, right? So we will see that here. Let's say so this is the code for I equal to 0, I is less than 10, I plus plus, and we want the statement to be executed as A equal to B plus C. So initially initialization has to be done, so I equal to 0, then the labels has to be there. So everything, see, understand, while loop, for loop, and any sort of loop that we want to execute in any of the code or any of the high level language, these codes are going to get converted into if, then and go to statements only, right? So in the 3 address code, on the intermediate code I am talking of, at the intermediate code there is nothing like for loop or while loop, everything gets boiled down to if, then, go to, right? So identifying the loop is very important. In the initial videos of identifying the loop, no, I have told you how the using that basic functions, no, how to identify the basic blocks, and from that basic blocks the leader functions and leader points, and using that, no, I told you that, no, the graph could be prepared and the loops can be identified, right? Okay, please go through those videos once and then come back to this. Okay, so if I is less than 10, the condition is if I is less than 10, go to some level, go to last, and T1 equal to B plus C, A equal to T1, right? And then T equal to I plus 1, I equal to T. So that is fine, the incrementing part, and then go to L. So it will remain inside. When it will come out, it will come out only when the value of I is greater than 10. So until the value of I is less than 10, it will remain inside the loop, it will execute the statement, no, T1 and T will be in operation, and then they will go to L will continue. But when this condition is false, it will come out, go to last. So it will come out and then it will be executing the remaining part of the statement. There also it will be having some intermediate codes only, no, it will not be like, no, it will be having some while loop or for loop. These are the examples that I am telling you, that it will be converted into this type of statements. So we have seen the while statement, for statement, and so on, right? Then we will see the other examples of the constructs, like switch construct. Let's say switch I plus j, right? There is a high level language switch I plus j, and case 1, case 2, and some default, right? So if the case 1 is true, then it is something like A equal to B plus C, it will break from that point. If the case 2 is there, P equal to Q plus R, break from that point, and default is X equal to Y plus Z, and it will break from that point after that. Anyway, if you don't write the break after the default, by default it is, there is a break which is present. Now our objective is to prepare the appropriate intermediate code of the 3 address code for the switch statement. So we have seen that, no, those 7 statements, within that, no, everything was supposed to be there, that really binary operator, unary operator, then the assignment, conditional go to, unconditional go to, array indexing, and pointers. So any of the high level language will be making sure that, no, your code would be converted into any of these 3 address code representation. Anyway, so using those things, no, we are coming up to this place for loop, while loop, switch, conditional, and so on, right? Conditional statements and so on. So here, coming back to this, T equal to I plus j. So T equal to I plus j, if you see here, I'm putting it side by side so that now it becomes easy for you. T equal to I plus j, because we need to execute the various cases, right? So I plus j value will perform the test, right? And go, so what it will do is go to test. So there is a test block which is present here, right? So if T equal to 1, go to L1, if T equal to 2, go to L2, else go to L3, and then the last. So this is how, the various cases would be coming up into execution. Just see here. Uh, what will happen is go to test. So that test part, you will make a jump to the test, and then if t equal to 1, what it has to do is b plus c is supposed to be executed given to a. So that is given to t1 and then t1 to a, and then finally it is saying go to last, right. So if t is equal to 2, right, if t is equal to 2, then what will happen is if t equal to 2, it has to make a jump to L2. So it will make a jump to L2 where it has to say execute q plus r. So it will execute q plus r and store it into p. So into t2 initially, and then from t2 to p, and then it will make a jump to go to last, right. And finally, no, that is the default case is nothing but x equal to y plus z that we want to execute. So go to L3. L3 is saying y plus z given to x. So t3 equal to y plus z, then t3 is stored to x variable, then finally again go to last. So initially, no, go to all 4 go tos, no, in the L1, L2, L3, no, just look into it. Before L1 there is there, before L2 it is there, before L3 it is there, and finally go to last. So and go this, no, initially will be kept blank, and then no, we will have to do the backpatching for that. So this is how, no, the switch statements will be getting converted into the intermediate code representation using 3 address code. There are few other things also which would be there, that is related to the two-dimensional array. So if you see here two-dimensional array, we will look into it little later. Just a minute. Okay, so in two-dimensional array, let us see that, no, how to represent it. X equal to a y comma z. If you look into this, x equal to a y comma z, a is having some address, right, that is something like base address, and y and z is nothing but the dimensions which are supposed to be there. So how to convert this into the representation? So normally what happens is, no, you need to make sure that, no, this y and z. So this y, let's say, is having some 20 elements. So y into 20, that is number of elements which are going to be there. So let's say if a 2 comma 3, so that means you have to cross 2 rows, then 3 elements in the next row, right. So in that way, if you see, you have to cross the elements here, and then make sure that, no, you jump, make sure that you point to the appropriate offset. So we need to calculate the offset and then add it to the base. So we are just calculating the offset here. T1 equal to y into 20, T2 equal to T1 plus z, T3 is equal to T2 into 4, assuming that, no, the 4 is the size, and T4 in that case will give you the base address of A. Let's say T4 equal to base address of A, and then finally I am saying x equal to T4 bracket T3. So this is nothing but addition of base plus offset. So in memory, one element can be can take more bytes also, right. So here let's assume that, no, one element takes 4 bytes. That's why, no, we have written into T3 statement that T2 into 4, right. So what will be the situation? So y into 20, what we have done is, we have done y into 20 plus z, and that is to be multiplied by 4. That is what we have done. So that is going to give us the offset, and we need to add this offset to the base address. So that is which is available at T4, right. So at T4 the address A is present. So A plus X, we are interested to do this, which is nothing but the offset, right. So in order to understand this, no, we should know how is two-dimensional array stored in memory, right. So without understanding this, it is a bit difficult here. So let me take you through this. In order to understand this, we need to look into this part. So let us assume that there is an array A 4 cross 4, right. So this is two-dimensional array, and how will the elements be in the array? Assuming that the indices starts from 0 and we go till n minus 1. So there is something like 0 0 0 1 0 2 0 3, then 1 0 1 1 1 2 1 3, 2 0 2 1 2 2 2 3, and 3 0 3 1 3 2 3 3. So in this way, the memory is going, your elements are supposed to be there, right. So memory, you are supposed to store this inside the memory in a single dimensional way only, right. So memory is a kind of single dimensional array. Now when you are looking into this array, there would be two ways in which the representations could be stored in the memory. One is row major order, that is RMO. Here I have written shortly is for that RMO, wherein all the rows will be stored 0 0 0 1 0 2 0 3, then 1 0 1 1 1 2 1 3, 2 0 2 1 2 2 2 3, and 3 0 3 1 3 2 3 3. In this way the storage, if it is there, then we call it as row major order, and mostly this is the default storage mechanism inside the memory for the array. And the next other possibility which exists is the column major order, right? So you see that 0 0 1 0 2 0 3 0. In that way, if you store the elements, first column, second column, third column, fourth column, that is how if it is stored, then we call it as column major order, right? So these are the two possible ways of storage mechanisms for the array. However, we are interested to jump to the appropriate offset. So array could be multidimensional. We don't have any such representations in the memory. So memory is nothing but a contiguous array, right? At high level language, user thinks that in his imagination that array this is there, but at low level language, what the thing is that the implementation what implementation you are going to store is like it is going to be in sequence, right? So just this is just for your understanding that the row major and the column major, if you don't understand it, then it is difficult for us to reach to the appropriate offset locations. So taking this as an example, let's say A to 3. So if A to 3 is supposed to be executed, then you have to cross two rows. You have to cross two rows and three elements in the next row, right? And three elements in the next row. Just see at the bottom. So let's say if A is equal to 100, that is nothing but the base location. And so what will happen is 100 plus something has to be there. So what will be that? 100 plus if there is only one dimensional array, in that case you need to make a jump to some specific location, right? So what will be the situation? So just referring to this equation, y into 20 plus z into 4, you can say here it is nothing but 2 into 4 plus 3 equal to 11 in one dimensional array. So 11 into 4 will give you 44, right? And each element is of 4 bytes here. That's why 100 plus 44 equal to 144. So in this way, we have seen the various possible ways in which the intermediate code is represented. So all these 7 types of high level language statements, binary operator, unary, assignment, conditional goto, unconditional goto, array indexing, pointers, and the various representations like quadruple storage representation, quadruple, triple, indirect triple, with the advantages and disadvantages. We have seen backpatching, the concept of backpatching. We saw the compound condition, while statement, for statement, the switch case statement, and the two-dimensional array representations also we have seen. So I think this is more than sufficient for you to refer to the intermediate code. Have a look at it once or twice if you are not able to get it once, and come out with your difficulties if any. Thank you.